Good day, everyone. This is Cadet Serafina speaking from Group 7, and we're going to report about the compass variation and deviation. So, all information on a chart, including your own plotting, is related to true north. Thus, all bearings on a chart are related to true north. Compass point to magnetic north, which varies from true north by an error called variation. So, what is variation? This simply means that the difference between your true north and magnetic north is your variation. This is the error caused by the Earth's magnetic field. For a magnetic compass, the needle will point towards magnetic north rather than true north, depending on where you are on the Earth's surface. This difference may be as much as 30 degrees. Variation may be to east or west of true north, again, depending on where you are on the Earth's surface. Variation also changes as time progresses, as the magnetic north pole changes position. This information is always shown on maps and charts, usually in the compass source, with a base year and a statement to say increasing each year. So, compasses also are subject to their own errors. This is called deviation. So, what do you mean by deviation and its own error? So, deviation is the error in reading a bearing from the compass caused by the magnetic influence of some nearby object, such as metal or post or an engine. In the case of boats, it may even be due to the material from which the boat is constructed. Electric currents close to the compass may create a magnetic effect. To avoid this type of error, the compass should be kept away from all such influences. Most boats have measured a deviation which should be minimized by careful mounting of the compass. Deviation changes each time to the boat alter course. There are also people skilled in the compass adjustment who can issue a card from a particular compass with deviation listed for changes in the direction. This is particularly important for headings where a significant deviation exists. So, compass bearing is equal to true bearing add subtract magnetic variation or add subtract compass deviation. Magnetic variation is due to the different positions of the geographic North Pole and the magnetic North Pole. The boat's compass and a hand bearing compass point to the magnetic pole, but all bearings on charts are related to the geographic pole or the true north. So, as you can see on the diagram below, it is a west variation. In that particular circumstance, the magnetic bearing is greater than the true bearing. Around Yukiko's variation is around 4 degree west to 7 degree west. In other parts of the world, it can reach more than 50 degrees east or west. It is because the magnetic north pole moves, the variation changes from year to year. The compass source on the chart gives you the annual change around 7 degrees east per year around the Yuki. For an 1870 version of variation at 18 degrees, you can see the chart of 1870. We therefore have to convert our true bearings into magnetic and vice versa. The simple way to remember is that whenever the variation is west, the magnetic bearing will be the greater than true, as you can see in the diagram above. You have to add variation to true bearing to get the magnetic, or subtract variation from magnetic to get true.
Variation west, magnetic west. Variation east, magnetic east. So variation will be west if the magnetic bearing is greater than the true bearing, and if the magnetic is less than true bearing, it will be variation west. So both themselves can also affect compasses due to their constructions. Steel engines kill ferromagnetism, electromagnetism, such as loudspeakers, mobile phones, handheld VHF, and the cargo on large ships. So this effect is called deviation. It will vary the heading of the boat. If your ship alter a course, then there is a tendency that the deviation will change. Compass adjustment, compass deviation card. In this card, it will illustrate the deviation. And here we can see the changes and how to calculate the deviation in order to apply when getting the compass error and others. So the standard compass error is determined at least once per watch and when possible after any major alteration of course. The standard and gyro compasses are frequently compared and repeaters are synchronized with the master compass.
Swinging the compass. Compass has its own problem, and it is deviation. Deviation is the problem of the compass error due to structure of the vessel, proximity of metal, objects, magnetic fields, or electronic equipment. It may be influenced by loading cargo such as canned fruit or having repair work done, such as new metal parts of electronics. Deviation also varies with the ship's head, as this changes the position of the magnetic fields in the boat relative to the Earth's magnetic field, as well as its relationship with interfering objects on board. So the first thing that we should do is to locate two transit objects or objects in line and determine their true bearing on the chart. Second is to secure the boat at anchor so that these transits are exactly aligned, and then swing the boat's head until it is pointing due north. The third one is read off the transit bearing on the compass and apply the variation. Next is the difference between this result and the true transit bearing is a deviation on this heading. If the true bearing is greater, the deviation is named east. If it is the lesser, the deviation is named west. Next is repeat the procedure taking transit bearings of each of on each of the cardinal points. Lastly, from the results, make up a deviation card. Further errors are caused by both heel and the difficulty of reading when on a moving platform. An electronic compass can be set up to remove the effect of deviation, but it is still a magnetic compass. Hand bearing compasses usually show very small deviation effects, which can be ignored if you use them away from a magnetic area. Deviation can also be east or west, but the same logic applies. Deviation west, compass best, and deviation east is the compass least. Thank you.
Summary and examples. I know that we are familiar of using TVM DC and CDM VT methods. So, in the diagram that is shown, as we can see in the arrow that going to the right, that is the use of TVMDC method. So if this is the method, and then if the variation is west, then you will add this one. You will add the variation, and then subtract if the variation is s. Then it is also the same, and if it is west, add west deviation, then subtract east deviation. And then as we can see the arrow that is going to the left, that is the use of CDMVT. So the rules in using the CDMVT: subtract west variation and then add east variation. Then also subtract west deviation and then add east deviation. So for the examples, the true bearing is 273 degrees true, and then the variation is 5 degrees west. So in this example, we are using the method TVM or TVMDC. So in TVMDC method, if the variation is west, clearly we must add this one. So 273 degrees true plus the variation of 5 degrees west, and then we can get a 278 degrees magnetic bearing. For the next example, it is the same method, which is the TVMDC. So the true bearing is 008 degrees true, and then the variation is 13 degrees east. So in the rules, if the variation is S, we must subtract this one. But before you subtract this one, as we can see, the true bearing is 008 degrees. So we must add first 360 degrees so that we can get 368, and then subtract the 13 degrees east variation, and then we can get the magnetic bearing, which is 355 degrees. So more variation and deviation examples. So complete the table below. So this is here we have 8 examples of the method. The 8 examples of the method TVMDC. So for the first example, we must need to get the magnetic and the compass. So as we can see, the true bearing is 114 and the variation is 4 degrees west. So since it is the method TVMDC, if it is west, we must add this one. So 114 plus 4 degrees west, we will get the 118. And then as we get the 118, as we can see, the deviation is 5 degrees east. So east means subtract. So we must subtract the 5 to 118, and then we will get the 113. And then for the next example, the true bearing is, we don't know what is true bearing, but we have variation and the magnetic. So we get, if we can see, we have 7 degrees west in the variation. So west, we must add this to the true bearing so that we can get the magnetic. So since the magnetic is 309, it's clearly that the true bearing is 102. 302. Or let's just use the method, or let's just use the method CDMVT for this one, so that it is easily to us to get the true bearing. So if you're using the CDMVT, the west is always minus, so we will minus the 7 degrees west variation to the magnetic, and then we will get the 302. And then for the deviation, the compass here is 314, and then the magnetic is 309. So it means that the deviation must be west, because the compass here is getting bigger. So in order to have the 314, we must add magnetic, which is 309. We must add 5 degrees. So the deviation is 5 degrees west. And then for the third example, the true is 050 degrees, and then we have 6 degrees east. So east, which means minus, or let's just subtract. So we will get 044 degrees. And then as we can see here in the compass, the magnetic doesn't change, so it means that the deviation is 0. So for the fourth example, again the true bearing is missing, but we have variation, which is 2 degrees east, and then 248 degrees each. So if in order to have to solve this easily, we will just use the CDMVT method. In the CDMVT again, if S, we must add this one. So 248 degrees plus 2 degrees east, we will get the true bearing or true heading, which is 250 degrees. And then here in compass, since the deviation is west, 2 degrees west, so since again this is the TVM DC method, we must add the west to the magnetic, so we can have the compass 250 degrees. And then for the fifth one, 156, so the missing one is the variation and then the compass. In order to get the variation, as we can see here, the magnetic is getting smaller, so it means that the variation must be east. So in order to get the 148, we must know what is the number to subtract in order to get the 148. So the number will be 8, so 8 degrees east, so we can get 148 degrees. And then in order to get the compass heading, the deviation is 5 degrees east, so east we will subtract, then 148 minus 5, we will get 143 degrees. And then for the sixth example, 358 degrees, and then the variation is 9 degrees west, so the missing one is the magnetic and deviation. So 358, then 9 degrees west, so we must add this one, so 358 degrees plus 9, then it is now it is greater than 360 degrees, right? So it means that in order to get the answer, if 358 degrees plus 9, and then if you get the answer, you will subtract the answer to 360 degrees, and then you will get 0.077 degrees for the magnetic. Did you get it? Again 358 degrees plus 9 is 367, and then we must subtract 367 to 360 so that we will get 0.007 degrees. So 0.7, so we have now the magnetic. And then as we can see in the compass, it's getting bigger, so it means that the deviation must be west, so that we can add this one, so 0.07 degrees, and then the number to get 110 is 3, so 0.07 degrees plus 3 west, 3 degrees west is 0.10 degrees. So for the seventh example, the true bearing heading is 0.04, and then the missing one is the variation and the compass. So the magnetic is 358, so you can tell that how the magnetic becomes 358 if the true bearing is 0.04 degrees. So in order to get the 358, we must add 360 for the to the 0.04. So 360 plus 4 equals 364, and then the 358, we must minus that we must subtract the 358, so the difference is 6. So since we subtract this one, clearly the symbol is S, so the variation is 6 degrees S. And then for the compass, the deviation is west, so we must add this one. So 358 plus 4 degrees west, we will get the 362 degrees. 362 minus 360, and then we will get 002, which is the compass. Then for the last example, the missing one is a true and then the magnetic. So in this case, we must also see what is deviation and the compass. So the compass in here is 191, and then the deviation is 3 degrees east. So east, so it means that the deviation is being subtracted to the magnetic heading. So but in this scenario, just like I said earlier, we must use the CDM-VT method so that it can be easily to know what is the magnetic. So using the CDM-VT 100, so you will solve this by reverse. So because CDM, we will be using CDM-VT. So 191, then 3 degrees east. So in the CDM-VT method, the east is addition, or we must add this one. So 191 plus 3 equals 194. Get it? And then 190, so the variation is 6 degrees west. So west in the method CDM-VT is always minus. So 194 minus 6 degrees, we can get 188 degrees. So that is all for our report, gentlemen. Have a good day to us. Thank you.